Violina Popova, software developer at Click My Horse TV, and my journey to React Native started in a place that might sound familiar to many of you. A web development team, a routine coffee break, and a manager that asks an unexpected question. Back in 2019, I was working as a web developer, and during a coffee break, my manager asked me, "Do you like horses?" The only context I had for horses was a joke in the office about new mobile project. And my instant reaction as a web developer with React was, I have no experience with React Native. And his response was familiar to many of us. He said, "But you have experience with React, that's enough." And that was the start of a wild ride. I walked into that project thinking my React web skills would carry me through, just like my manager thought. But I quickly learned that React Native isn't just React for mobile. It's a different beast with its own rules, challenges, and quirks. It took a lot of late nights and a lot of debugging to figure out the things I'm going to share with you today. And I'm here to share what I wish I had known back then. The critical differences between web and native development in the React world, and how understanding them can save you from frustration and help you build mobile apps that truly shine. First, let's understand why React Native even exists. It's a question I had to ask myself as a web developer. Why not just use mobile website? The story begins over a decade ago, in 2012, when a giant in the tech world made a crucial decision. Facebook announced that they are becoming a mobile-first company. They noticed that their users were spending more time on their phones than on computers, and they needed their product to be amazing on these devices. The problem was, the majority of their engineering team were web developers. They tried different options, but they stay away from solutions like Ionic, which is essentially just put a web app inside a web view. The performance was sluggish, and this wasn't what Facebook wanted. They wanted something new. At an internal hackathon, a small team created a prototype that could generate native mobile UI elements from JavaScript. This successful experiment led to the development of a new framework announced at 2015 at React.js Conf, and with the core philosophy, learn once, write anywhere. That's how React Native was born. This wasn't about writing a single code base that compiled to every platform, which is what the old-school hybrid frameworks promised. This was about reusing your knowledge, your patterns, and the way of thinking about building user interfaces and applying that to a new target. Okay, let's pause for a moment and just answer a simple question. What is a mobile app? From a web developer's perspective, it feels natural to think, I deploy my code, I refresh the browser, and users instantly get the latest version. But mobile doesn't work that way. In mobile, your JavaScript isn't just floating around in a browser tab. It gets packaged up, compiled, signed, and shipped as a binary. That little app icon you download from the App Store or Google Play, that binary is the actual product. So when you hit publish, you're not just pushing code. You're creating a signed artifact that goes through App Store review. IPA for iOS and IPK for Android. This artifact has to pass validation and then lives on someone's device. That's a huge mental shift for web development entering the React Native world. So now that we've established what a mobile app actually is, this is compiled binary with all your code and assets inside. The next logical question is how the JavaScript code, the thing we write every day, actually turn into a native app. That's where React Native really gets interesting. Because under the hood, it has to connect two very different worlds. The JavaScript world that we are comfortable in, and the native world of iOS and Android. In the early days, these connections happened through something called the bridge. Imagine it like a postal service. JavaScript would package up a message, send it across the bridge, and eventually native would respond. It worked, but it was asynchronous and sometimes slow, especially for complex UI updates or heavy interactions. Today, things have evolved. We now have GSI, the JavaScript interface, and instead of passing messages back and forth like letters in the mail, GSI is more like a direct hotline. JavaScript can call into native functions synchronously in real time without waiting for a round trip across the bridge. This shift from the old bridge to GSI is a game changer. GSI unlocks two incredibly powerful features in modern React Native that directly address the performance bottleneck of the past. First, let's talk about how it makes your app start up faster and feel snappier. Remember how I mentioned that mobile apps bundle everything. This includes all the native modules your app might use. Things like accessing the camera, Bluetooth, or even complex animation libraries. In the before times, with the old architecture, your app would try to load all these native modules right when it started up, regardless of whether you needed them immediately. You can imagine how that might lead to a slow, sluggish launch. It's like trying to carry every single tool in your toolbox with you everywhere, just in case. Turbo modules change this entirely. Thanks to the JavaScript interface, they allow us to lazy load native modules, and instead of loading everything on startup, modules are loaded on demand only when your app actually calls for them. This significantly reduces the initial overhead, leading to a much faster startup time and a smoother initial experience for your users. All right, so Turbo modules give us faster startup times by being smart about when we load native code, but once the app is running, how does our React code actually draw things on the screen? How does it create those beautiful, fluid native user interfaces? This is where Fabric shines, and it's a huge step forward from the older architecture. In the before era, when your React component wanted to update something on the screen, let's say a button, changing color, or list growing, that command had to travel across the old asynchronous JavaScript bridge. This delay, even if tiny, could lead to dropped frames, janky animations, and that not quite native feel. The result? A slow, less responsive user interface. The after era part shows that your React component can now communicate directly and synchronously with the native UI. There's no more asynchronous back and forth across a slow bridge. Instead, when your React code wants to render or update a UI element, it uses GSI to make a direct call into the native rendering layer. This means that your JavaScript and the native UI are now much closer in real-time sync. What does this direct synchronous communication mean in practice? It means smoother animations because updates happen instantly. Animations become much more fluid, more responsive interactions, Taps, swipes, and gestures feel snappier, just like a true native app. And better user experience. Overall, the app feels more polished, performs better, and provides that premium native feel users expect. Fabric fundamentally changes how React Native renders UI, eliminating a major source of performance bottlenecks and bringing us closer than ever to truly native performance directly from our JavaScript code. I've spent a lot of time talking about the why React Native exists, and the how the new architecture with GSI, turbo modules, and Fabric makes it all work. But as a developer, the real question is, what does this mean for my day-to-day coding? What do I actually do? The first and most obvious change you'll notice is the fundamental building blocks themselves, components. This code looks almost the same, right? But the view is a native UI kit view on iOS or Android view on Android. As a web developer, the first thing that hits you is that you can't use the building blocks you've relied on for years. You instinctively reach for a div, span, an input tag, or a button, but they simply don't exist in React Native. Instead, you use core components that map directly to the native UI elements. Think of it as relearning your HTML. Instead of div, you use view. Instead of span, you use text. Instead of input, text input. These aren't just semantic changes. They are the actual native components from iOS and Android. And to really understand what's happening under the hood, we need to know what frameworks those components belong to. So, what exactly is the view component on a user's phone? On Android, that view is rendered as a native Android view. The modern Android development world is built on a set of libraries called Android Jetpack, which provide the building blocks and best practices for creating a modern Android UI. On the iOS side, that same view becomes the UI view. These are the core classes from the foundational framework called UIKit, which has been the standard for building iOS user interfaces for over a decade. Similarly, with the text component, on Android it becomes text view and UI label for iOS. Now it's worth mentioning that just as React Native is evolving, so are these native platforms. Apple has introduced SwiftUI, a new declarative framework that is in a way very similar to the React model. So when you write a React Native component, you are essentially writing a set of instructions for the JavaScript engine to go and tell these underlying native frameworks like Jetpack on Android and UIKit on iOS what to render. This brings us to the next big mental shift, styling. This is probably one of the initial hurdles for web developers. You can forget everything you know about external style sheets, CSS preprocessors, and even class names. In React Native, all styling is handled with JavaScript objects. You use stylesheet.create. This method takes a style object and creates a unique immutable reference to it. It's a way to get performance benefits because React Native can optimize how these styles are processed. You can still use Flexbox for layout, which is a huge win for us as web developers. But be prepared for a slightly different implementation. For example, flag direction column is default, unlike row for web. And many of the CSS properties you're used to, like box shadow, border radius, and even some sizing rules work differently or have different names. This is where that learn once, write anywhere philosophy is tested. Now we'll talk about navigation. In the web world, navigation is easy. It's built into the web browser. You click a link, the URL changes, and the browser handles the rest. Your back button just works. In a native app, there's no browser and no URLs. You are not navigating to a new web page. You are managing a stack of screens. Think of it like a stack of playing cards. When you go to a new screen, you push a new card on top. When you go back, you pop that card off the top of the stack. This is a fundamental shift in thinking, and for a long time, this was a pain point in React Native. We now have an incredible library called React Navigation, which is the standard for handling navigations in React Native, and it allows you to easily create those text navigators as well as tab and row navigators that feel exactly like a native app. This is an area where the web analogy completely breaks down and you have to embrace the native paradigm. In this code example, Create Bottom Tab Navigator provides the functionality to build a tab-based navigation interface at the bottom of the screen. Navigation container wraps the entire navigation system, managing the navigation state and ensuring the app's navigation works smoothly across different screens. Tab Navigator defines the bottom tab navigator, which organizes the tabs and handles the transition between them. And each tab screen represents one tab in the navigator. The name prop, for example, home, sets the label for the tab, and the components prop, like home screen, links to the screen component that will be displayed when the tab is selected. The snippet includes 5 screens: home, live, events, horses, premium, and it's the same thing you see at the bottom on the right side of the screen. So, what do you use when things go wrong? When your network requests are failing and your app's performance is tanking. You don't have a browser to fall back on. We have Flipper. Flipper is your central hub for debugging in React Native apps. It's an extensible desktop app that allows you to inspect your app's internals in a way that feels a lot like those browser dev tools you're used to. It's an absolute game changer. But there's one more piece of the puzzle that every developer needs to understand, and that's the local setup and build process itself. The way your code gets from your text editor to a running app on a device is a workflow that can be either your best friend or your worst enemy. At the center of this process is Metro, which is React Native's JavaScript bundler. You can think of it as the equivalent of Webpack or Vite for your mobile apps. Its job is to take all your JavaScript files, images, and other assets and build them into a single optimized package that the mobile app can read. But Metro is only half of the story. Once it has bundled your code, that package has to be integrated into the native app's build system. For an Android app, this is handled by Gradle, and for iOS app, it's handled by CocoaPods and Xcode. These are the tools that compile the native code and assets and combine them with the JavaScript bundle to create the final, signed binary file that runs on the device. And this is the core of the local setup. Understanding how these pieces fit together is crucial for troubleshooting and navigating the build process, which is often a source of confusion for developers new to React Native. So if a local setup can be so complex, what's the solution? For most of the teams, especially those without deep native expertise, the answer is a framework called Expo. Expo is a powerful set of tools and services built on top of React Native. Its entire purpose is to abstract away the complexity we had just talked about. It handles the native build process for you in the cloud. That means for many projects, you don't need to have Xcode or Android Studio installed on your local machine to get a working app. It's a huge deal. It's what allows a web developer to truly learn once, write anywhere, without getting bogged down in the complexities of the native world, of the native build process. Expo provides two huge wins for any development team. The first one is zero config development. You can start a new project and run it on your phone in minutes by simply scanning a QR code with the Expo Go app. This is the fastest way to prototype and develop. And the second thing is over-the-air updates. That allows you to push new JavaScript code directly to your users' devices. This means for most bug fixes and small feature updates, you don't have to go through the lengthy App Store review process. And while not suitable for every single app, projects with very unique, highly specialized native requirements might need the bare workflow. Expo has matured into the recommended starting point for the vast majority of React Native projects. It puts the focus back where it should be, on building great features with JavaScript. So we started with a simple question: is React Native just React for mobile? And I hope that after this talk, you have the answer. I know this might sound like a lot, but remember where we started. The core promise of learn once, write anywhere isn't about the code. It's about the patterns. It's about how you think about building user interfaces. So let me ask a question. Who here has React experience? Congratulations. You're halfway to mobile development. Don't be fooled. React Native isn't React on a smaller screen. It's a different beast with its own learning curve. But once you understand its differences, your React skills don't just transfer, they take you further than you ever thought possible. And when the major companies like Amazon are investing heavily in React Native for their TV apps, this is definitely a signal. This isn't just for phones anymore. It's a powerful framework for building compelling experiences on any screen. Thank you.